So we've seen a lot of the codes now in the assembly language, the instructions. So let's take a look at what the rules are for labels in assembly language and try to understand a little bit about the assembly language and why we're using it and why we're not using what are called higher level languages. First, the labels. By choosing labels that are meaningful, a programmer can make a program much easier to read and maintain. There are several rules that names must follow. First, each label must be unique. The names used for labels in assembly language programming consist of alphabetic letters in both upper and lower case, the digits 0 through 9, and special characters like the question mark, a period, the @ sign, the underscore or the underline, and the $sign. The first character of the label, though, must be an alphabetic character, so you cannot use a number. Every assembler has some reserved words that must not be used as labels in a program. Foremost among the reserved words are the mnemonics for the instructions. For example, we've seen move WL and add WL. Well, these are reserved because they are instruction mnemonics. In addition to the mnemonics, there are several other reserved words. We'll have to check the assembler list to determine what those other words are. Now we'll look at the introduction to PIC assembly programming. In this section, we'll discuss assembly language format and define some widely used terminology associated with assembly language programming. While the CPU can work only in binary, it can do so at a very high speed. It's quite tedious and slow for humans. However, to deal with the zeros and ones in order to program the computer, a program must consist of zeros and ones, and it's called a machine language. In the early days of the computer, programmers coded programs in machine language. Although the hexadecimal system was used as a more efficient way to represent binary numbers, the process of working in machine code was still cumbersome for humans. Eventually, assembly languages were developed, which provided mnemonics for the machine code instructions, plus other features that made programming faster and less prone to error. The term mnemonic is frequently used in computer science and engineering literature to refer to codes and abbreviations that are relatively easy to remember. Assembly language programs must be translated into machine code by a program called an assembler. Assembly language is referred to as a low-level language because it deals directly with the internal structure of the CPU. To program an assembly language, the programmer must know all the registers of the CPU and the size of each, as well as other details. Today, one can use many different programming languages such as BASIC, Pascal, C and C++, Java, and numerous others. These languages are called high-level languages because the programmer does not have to be concerned with the internal details of the CPU, whereas an assembler is used to translate an assembly language program into a machine code, sometimes called an object code, an opcode, or an operations code. High-level languages are translated into machine code by a program called a compiler. For instance, to write a program in C, one must use a C compiler to translate the program into machine language. Next, we look at a PIC assembly language format. We're doing assembly language because it will help you to understand how the data moves through the microcontroller. If we started with the C compiler and the C language, you wouldn't have the understanding of how the information moves through the stacks and the registers. And it's actually better that you get this understanding because you will have an idea of what you need to do and the things that that occur in the registers in the microcontroller. So the next thing we'll look at is the structure of assembly languages.